Hi everyone. Today I am going to discuss about xargs command in Unix. So let's get started with that. So xargs, args, xargs means x arguments. So this command is present in user bin xargs or maybe in bin xargs. You just run the which command on it, you'll know. So what is the requirement and why do we need xargs? What is there which we cannot perform? So let's try to analyze it. For example, I make a file f1, okay? I can do ls f1. It gives me f1. If I want to remove f1, obviously the answer is I can simply run f1 rmf1 and it will be deleted. But for example, some of you may be confused by this command. For example, if I write lsf1, which is the output, the standard output of this command would be f1, as you know. And if you pipe in this this command means the f1, the f1 standard output would be the input of, let's say, another command rm, and we think that it might work, okay, because we are putting the feeding the input standard output f1 to command rm. This may not work. Why? The reason is that rm, the remove command, requires an argument to pass, and pipe is not ls space f1 pipe rm. This command is not able to do that because essentially rm requires a argument to pass on so that it can remove the required file. So this is why in such situation also you will know that uh, xargs can be very handy. So we will talk about that. So before I start, you should know that you can check the help of xarg by man xargs. That's one. Or you can also do info space xargs. So these two commands can be used. Okay, so let's try to run only xargs without any argument. Okay, just hit enter and you are into a new line. Now you have to type something here. Let's say I type hello, and after I type hello I do control D. Control D is to quit from the current process. So I do control D here. Okay, control D. So what do you see that as soon as I hit on control D, I get exact the same output what I wrote in xargs. So basically this is what xargs does. Xargs, if nothing else is given, xargs will run the echo on it simply. So we'll touch more on that. And now again, if xargs command is successful, the exit status of xargs would be 0. So if there is an error, then exit status would be non-zero from 1 to 255. Right. So let's just try to understand exargs with examples, and then you will understand it more and more with different options we give. Okay. So the first one would be I'll I'll discuss about the first option, which is -a of xargs, and we'll know what it is. Let me create a file called file. Okay. In this file, this is already I have created. You can see this file has 4 lines, 3 lines in it. Okay. Now all I'm doing is I'm running. You can do a cat file just to show you the output. Okay, right? So here I am running xargs -a. -a option we give when we are passing the file as input to xargs. Okay. So let's analyze what will happen. So I give xargs -a and then file name. And you see, interestingly, even if the actual file had 3 lines, right, separated by a space, and obviously here it's a new line character. So every white space of the file, whether it is a space or a new line, has been now converted to one space, as you can see. So hello there, hello there, how is as it is like this, and then new line is again a space here, and then again are you I am okay till here, and again tc by has come to the same line with a space. So this is what xargs can do for you. Okay, now and this is not actually showing much help here, but eventually you will get more sense of it. Okay, so this is the output you can see now. Right now I will also discuss one of the another command of xargs, which is, so basically these all are treat can be these all um, bits like hello there how can be treated as a argument to xargs. So we'll discuss that very soon. But before that, I will introduce another switch called -n, which we give to specify the maximum number of arguments per line. For example, if I write n-n2 for this same command, in this case, two arguments will be appearing in one line and then next two and so on. So let's run again and check. So you can see now two arguments hello there in the first line, then how are second, UI third, and so on. So this is how it is, and you can actually control. And if you don't give any n value, then everything appears to be on the same line. Okay, so this is about n command. Now let me also show you one thing. For example, if I write echo hi, right? Echo hi. And if I pass this to xargs, okay? So xargs by default run the echo on the input. So the argument is high and xargs is running an echo on it. So how do you know whether it is really doing it? You use a verbose -t switch with xargs, okay, and hit enter. So you can see it has xarg has run echo and then space high to get your output as high. So this is the default behavior of xargs. It runs an echo on it. Okay. So again, this is just the start, but eventually you will get to understand more of xargs very soon once I do or cover some more practical examples on it. Okay. So again, I will run the, if you remember, I started with this example ls, right? ls f1, right? And I tried here pipe rm. It did not work, right? Now let's try to do something here. I will say ls f1 and then pipe xargs, okay? Xargs, okay? So first let's run this one. You can see it is only coming f1 as output. Why? So if I run a -t here, you will see the echo command has run automatically on this argument because the input is ls f1, which the input to xarg is only f1, okay? Because ls f1 is giving only f1, right? In the output. So the f1 is feed to um, xargs command, and xargs run an echo on that output of lsf1, which is f1. So hence you get a f1 as an output. Okay, this is what it is. So now what I'll do, I will add rm. Okay, now what will happen, what xargs does, that after this command, whatever comes as an input, standard input, that whatever comes as an input which is coming from the pipe, right, that will be put as an argument to this command rm. Okay, so let's run this command and you can see this time echo has not run, but what it has run, rm, space whatever comes from standard input, which is F1. Okay, so now you can see F1 is removed. If I run ls F1, nothing is found. This is the basic use of xargs. Xargs can be used in such situation very easily. Now question is, you can always run RMF1, right? Then what is the use of xargs? So eventually you will know once we get to know little bit more examples, right? So let's just try to cover another example. So file names are terminated by null character by -o. What is the use of it? Okay. So let's try to create a file, new space file. In this specific example, I am I'm creating this file, new file. This is the file, right? And let's try to run a find command on this file. So the name is new space file, right? Let's run it. It finds this file, as you can see. Now, if I want to pass this input, new file to xargs, right? Xargs. So it is coming correctly. Now let's do a verbose. It is also coming correctly. Now we will try to run RM on it, okay, and see what will happen. Okay, you can see it has tried to run RM on new separate and file as separate entity. It says new file not found or directory not found. That's the reason, because xarg is splitting this white space, and hence new is a separate entity and file is a separate entity according to xargs. So what you can do in this case, you first find you use the find command and use the output of this file um, as a null character separated value. So use print 0 for find command and hit the enter. You can see the output is coming as this line here now, because it is not new line separated or space separated, it is just the null character separated. If you do that, and if you pass this output to um to xargs, srgs minus 0, okay, let's run. So you can see that if you had minus n1, okay, for xargs, you can see everything is treated as one entity. If I do that, okay, one entity, you can see here. So if I do n2, then obviously there is no more 2, and if I do n1, it is still taken as 1. But if I don't use, for example, print 0 and no minus 0, then let's see what will happen. You can see here it is splitted into two different entities, okay, and that is the reason why we need this together. Okay, now just run an RM on it and let's see what happens. You can see that new file has been deleted. So this is the whole idea about minus 0, not minus o, minus 0. Minus 0 is used in xargs when you are dealing with file, um, especially the files which have spaces in between or quotes somewhere, so that they can be ignored actually to treat as a complete entity. So the null separated or null character separated value will be helpful when you run find command. Just use the same print 0, okay, print 0, which will give you the files with null separated, not space separated or new line separated. Hence, on that output, you just use xargs with -0 option to remove it or do any processing, just not remove, but move or copy or whatever, or make a tar, anything you can do. Okay. So this is it about this file, this -0 option. Okay, let's just move to the next option called -d, which is a delimiter. What is the use of delimiter? It's very simple. So let's say I write here d1 underscore, let's say d2. Let's say simple here to d1 d2, and I want to make d1 and d2 as two directories. Okay, what I can do very simply is you can run xargs. First I will just run xargs and show you the result. Okay, and then use the -d option and pass the underscore as a delimiter. Okay, and hit enter. So it will run echo by default, as you know, but you can see very clearly that this the underscore is has splitted d1 d2 separate. So this is what we need. Okay, and on top of it you again run one more time xargs. Okay, xargs one more time, args xargs. This will actually remove the additional white space around the d1 d2 base, means this new line thing will be gone. And now on this xargs simply run mkdir. Okay, now let's check our output, and you can see d1 and d2 have been now created for you. This is how it is, and yeah, very simple use of it. Let me remove d1 d2 and this new dir as well, all of them. Okay, so this was about delimiter. Okay, now let me give you the next option, -i. This -i option is a replacement string option, very handy. What is the use case of it? Let's check it. So for example, so let's take this example cat file. Okay, okay, so the file is not there, that's okay. Let me just check. So we will use the file called host. Okay, so let's do cat host. So we have a host file where there are three web addresses are written. Okay, so what I can do here is pipe xargs, okay, -i, and -i option is a placeholder for your data. For example, if I run here, um, for example, if after I if I give this character, curly braces open and closed, okay, you can use any character. You can use here, for example, ABC. This can also be used, or anything else, let's say colon, a colon, anything can be used. Okay, but I'm using here curly braces open close. And now if I write some Unix command, for example echo, and here I say this is the host, and after that I use the same curly braces which I have used here, which will represent the standard input. So the cat host will give you google.com, amazon.com and yahoo.com, right? So this curly braces will represent google.com, amazon.com and yahoo.com one by one. Okay, so let's run it and check. So you can see the output is this is the host google.com, this is the host amazon.com, this is the host yahoo.com. This is what it is. Okay, very simple. This is one handy example, but I'll give you more examples of -i soon. Next option is -p, which is prompt option. So for example, let's see if I have a file, right? We have a host file, right? So let me try to create, I will run a host, ls host, and then I will use xargs, okay, -p, prompt. prompt will, it will ask before that operation is performed. Okay, so I will do the same thing here, minus I, and then curly braces open closed, and after that I'm running a command called UNIX. So this command will actually try to create a file called host.txt. Okay, and before it creates, it will ask you you want to create it or not. So let's check. Touch. So you can see the command is performed as touch space host.txt. You want to create it or not? If you say no, nothing will be created. You can check here host.txt, no file. If you run it again and if you say y, and if you run ls host.txt, you can see host.txt is created. Okay, it is an empty file because it's a touch command. So this is the minus p option. Hope you can understand it. Okay, next option is minus p, capital P. It is to pass the maximum number of CPU or processes for your command of xargs. Why it is important? Because let's check how many CPU I have in my machine. Okay, so I will run command called nproc. My machine has 6 CPUs. Okay, so I can easily, use 6 processes in parallel actually. Okay, because I don't want to overload one. But let me just give you an example so that you understand it better. For example, before that I will show you how can you run, um, for example, if you are running a sequence command, sequence 5, then 5 number from 1 to 5 will be printed, right, as you know. And then what you do on this sequence command, let me clean it, sequence command, you run xargs, okay? So this will give you 1, 2, 3, 4, 5 in single line, as you know, right? And minus n1 you know already, n2, so 1, 2, 3, 4 and then 5 in this fashion, okay? So n3, 1, 2, 3, 4, 5 in this fashion, n4 in this fashion, and 5 in this fashion, right? So this is very handy, but I don't want to explain you this. I wanted to explain something else. So if I write n1, so you know it is the same output as you know, right? Okay. Now I am passing a command called bash minus c. So bash minus c means you can run any command of bash by giving minus c option, bash minus c, and then here you can pass any command, let's say echo, for example, echo high, for example, this. Okay, so it will run echo high on all 5 lines, 1, 2, 3, 4, 5, as you can see. Okay, if you run echo high, and again if you run semicolon echo high or capital high, then it will run small high, capital high for all the 5 lines. Okay, this is how it is. Okay, but I don't want to run here echo. What I will do, one more thing also you should know, that if I am doing echo $0, so $0 in, if you run bash minus c, the $0 will represent whatever in this way, whatever is input which is coming from, or the argument which is coming from this command. So sequence 5 will, so echo $0 will represent 1, then 2, then 3, then 4, then 5. Okay, so this is what it does. So echo $0 will represent um, the uh, the positional parameter for which is coming from the input. Okay, so now what you can do, uh, I can do, I can run a sleep command on it, right? Sleep 1 second sleep. Okay, let me do one more thing. Let me increase the sequence from 1 to 5 to 10. So you can see it is printing all the numbers from 1 to 10 in 1 second delay. So all of this whatever I am doing, everything is this is being processed on using one CPU, okay? Because I have not given any processor. So what you can do here, you can add, for example, minus P1, it is the same thing, okay? Minus P1 is the same thing. So let's try to means use the one process, right? One processor. So what do you do? In front of it, use a time command, and let's try to analyze how much time it takes to run this xargs command when you are using P1. Okay. So after this command is finished, it will print the time spent on this activity with the time command. Okay. So let's check it. What do you see here in the end? The real time, which is the clock time, is is spent this much. Okay, 10 seconds maybe. Yeah, 10 seconds. Okay. Other times are not very important here, but this is one of the kernel time and also the user time, which is like when you loop something. But kernel time is like when you do exec command and so on. But real time is the call wall clock time. It's 10 seconds. Okay, 10. Remember. Okay, now what I'll do, I will tell XRs, okay, use two CPUs for the same process. Same command, use two CPU, not one. And let's try to analyze how long or how much time it will take now. You can see it is running two commands in one CPU, and you can see it is now the clock time is 5 seconds from 10, so it has reduced. Let me give one more example here. I will say use 4 process, okay, and let's see what happens. So 4 commands is running quickly, and you can see it has now reduced to 3 seconds. So that's how you can use your job in parallel. So it has launched 1 2 3 4 in one CPU, then 5 6 7 8 to next CPU. Sorry about it. 5 6 7 8 into next CPU, and 9 and 10 into the remaining 9 and 10 into another CPU. So that's how you have reduced the runtime. Okay, we are going in a good pace here, which is good. Let's just go back to some examples now so that you understand xargs better. So if you know, if you know cat host, we have three um, web addresses given, right? So let me introduce you a command called host minus t, okay, and then capital A, and then you give, let's say, google.com, okay. So basically this command will give you the IP address of this google.com. So if you rerun again, so you can see it is consistent here, but as you can see that this is coming like that. So you can now if I'll do same thing if I do for yahoo.com, okay, you can see it has several addresses, not just one, right? So let's try to do the same thing in using xargs, okay? So I do cat host and then pipe xargs, print one line at a time, means one output at a time, and then host minus t capital A. Okay, so let's see what is the output. So you can see it has a run for Google, and then Amazon has three output, and yahoo.com has these many outputs, right? Now, for example, if I have a requirement to only print the first, the very first line of every domain, means google.com only the first line, yahoo.com only the first line or the first output, and Amazon also only the first output. First, how can we do? So let's try, let's the very first thing you might think of using head command, right? So I'll show you something and then maybe we'll analyze what is wrong there, okay? So here in this example, if I run same command I'm using, but I'm here at the end, I'm using head -1, okay? So what is happening? The only very first line of that complete data is the very first line of the complete data is coming up like this one, as you can see. This is not what we want. We want google.com. This one comes also, Amazon comes the first line, and then go yahoo.com comes as third line. How can we fix this problem? Okay, this is not helping. So what you have to do is basically use your same concept of um, bash -c, okay, bash -c, and then you put your command in host minus, and let me also introduce that should not required, so we'll do host minus ta, and then we'll pass the argument of that domain by $0, as you know, okay, and then I am running a head -1 on at this level. That's it. So what will happen? This command will run head -1 for first domain, then for second, and then for third. Okay, let's run it again and check. So you can see now the very first line of all three domains is coming correctly. So this is very easy and this is very important or very handy to use bash -c when you know what commands you're dealing with and what sort of output you want. So I hope you understand this concept. Okay, so let's try to do this. ls, okay, ls abc. Okay, let's check the output. Okay, ls abc and then xargs -i. Okay, xargs -i touch dot txt. Let's run it and do ls. You can see it is now created. So basically when I run ls command, every entity like A and then B and C are treated separately. So let's run -t here to check what happened. So you can see when ls command is run, then it takes a.txt separate, b.txt separate, and c.txt separate, and you can create three files like that. Okay, so same thing what we can do is we can do ls a, b, and c, or maybe a.txt, or maybe star.txt. Okay, so let's check what is star.txt. Star.txt has 4 lines, okay, 4 files. So you can do xargs -i. Let's also add -t for your understanding. -i, okay, -i, and then you do cp. I'm using the cp command. I'm saying copy the a.txt or b.txt by this command, okay, all the files, all 4 files, copy them to same name but extension bk, back. Let's run and you can see you are able to run copy this to this, this to this, this to this, and this to this. So if I long list, you can see all the files are created correctly. Okay, let's remove all A dot star, B dot star, C dot star. Okay, and also let's remove A, B, and C. Okay, now we have clean file. I'll remove also host.txt and host.txt.backup. So we have a cleanup here. Okay, so let's continue. Let me give you another handy example. You know the cut command, right? So how can we use cut command? For example, I'll say cat /etc/password where we have all the users stored, right? Pass this information to cut command, cut minus D, and the delimiter of cut command I will use colon because the data is colon separated in this file, right? And I will pass this output to sort command, this input to sort command. So basically the data will be sorted. But before that, I will also let me also catch or cut only the first field. First field is the username in the etc password direct file. So I'm using cut minus D colon and then field 1. Okay, and then I'm sorting it out. Okay, so let's see what will happen. In this case, you can see all the users name are coming correctly in the in this order. Now they are coming into new line. Okay, but if you add a xargs, they will all will appear into one line separated by space, as you can see. Okay, so this is how it is and very handy. So obviously, if you want to get this data into a file, users, you can do it right like this. So let's do it in this way using redirection sign. And now cat users have got the required data we need. One example. Okay, let's do one more example. So I'll run the sequence command. Sequence 20 means 1 to 20. Run an xargs on it. Xargs on it. Okay, and I'll use minus I placeholder, and then I will do touch dot txt. Obviously, you know what I'm doing, right? I'm creating 1.txt, 2.txt, and so on till 20.txt. Okay, so let's check it. ls. Okay, you can see all 1 to 20 txt is created, right? Now, what I will do, I want to change the extension from txt to something else for 1 to 20 txt. How can you do it with xargs? So you can do ls star.txt, right? So you get all the numbers, right? 1 to 20.txt, right? Okay, use cut minus d again delimiter. Delimiter should be this time is dot. So you can use dot delimiter like that. Okay, so if I only run this command, you will know. So obviously I have to give the field also. Okay, minus F1. So you can see I get all the 1 to 20 numbers because the first field would be the um the the first part of the file, and second field would be the extension, right? So let's check extension.txt, correct? So let's go back to this. I will cut the first field, and now I will pass this to xargs. Minus I, use the placeholder to do some operation like move command and move the first part, which is 1 dot txt, right? 1 dot txt, 2 dot txt, 3 dot txt, and so on to 1 dot sh, 2 dot sh, 3 dot sh, and so on, right? This is it. Run ls. All the files have been changed from .txt to .sh by this command. Very handy, very easy to use. Okay, now let's try to delete them. Let's try to delete all that sh file. I know I can simply write rm star.sh, right? You can do it, but let's try to do it in different way. I'll run a find command with name and say please find all the .sh, right? Enter. You get all the sh, right? And then you run an exec on it, exec command on it, and run an rm on it. This is a find command has a switch called exec where you can run the UNIX command directly with the placeholder and backspace colon. This is what you have to give, okay, to run. But what is the objective? Objective is I will calculate the time of this command operation. Okay, let's run it. Operation took this much of time. Okay, maybe it is negligible, but it still has done it. Okay, let me create the file again. Okay, let me create the file again for sequence command like this. The txt I'm creating. Okay, and this time I will remove txt, but I will not use the exec. I will use pipe xargs rm. Okay, and let's check again. You can see even the runtime is reduced because this is fast. With exec is a system operation, means it goes into kernel, fetch that information, seeks the information from kernel. It takes more time. This is not kernel specific. You can see kernel here 44, so that's why it takes 44 seconds in here, whatever milliseconds. But here it takes less, so that's why it is all very fast. Right, what else we can do? So let's do ls. Ls, you know, right? How to reverse the order? Ls minus r, you reverse the order, right? You can do ls minus r pipe args, obviously xargs. Okay, cat. So you can see you can cat all the files with xargs, right? Which is being used here. So if I say ls space host, you can use cat command, right? Similarly, you can give all the files by this. It can still, you know, cat for you. But if you want to do cat on the reverse order, you can do ls minus r and then xarg. So it will do the cat command on the reverse order of ls. Okay, hope it is clear. Let's try to create a zip file. Okay, so I will say find. If I run only find, you will know all three years will come, but let's say find minus type f file type. So these three files have come, right? Xargs, which is good. Now let's run gzip on this. You can see how easily you can create gzip for all three files. Let's unzip them. So let's try if I run the find command again with type f, you can see it is still working. So you all you need is gunzip. You again gunzipped it. Okay, what else? So let's do ls readme. This is the file, right? And then you run an xargs on, and you run a word count on this file. You can still run the word count on this file by this method. This file has 98 lines, 405 words, and 1870 characters. It's very handy and easy. I hope you guys have understood xargs in pretty depth. If you have questions, please ask me in comments. Thanks for watching. Bye.